Hi everyone, this is Team 6, and for our final business analytical report, we're conducting analysis based on a Uber and Lyft dataset. Here's our agenda for today.
Here are the business questions we put together. We wanted to ask this specific question because we felt like the answer to this question are very crucial to people in the Boston area who wants to become a cab driver. Naturally, they would want to know the profitability of the ride-sharing business and the elements that might affect their profitabilities. As a group, our assumptions about some of the elements being that the company of the ride-sharing service, the day of the week, weather, locations, or neighborhoods. Move on to the introduction. We found our dataset on Kaggle according to the website. The dataset was collected real time from November to December of 2018 through an application they custom built. Originally, there were two datasets. The first dataset mainly has information about the rides, such as distance, cab type, time, destination, and price. The second one mainly has information about the weather, such as temperature, rain, humidity, and wind. Overall, we had confidence in our data quality due to its detailed collection method and its size. However, we're slightly concerned about the fact that datasets were collected from the most popular spots in Boston and during the months of November and December of the same year. So this may result in our sample not representing the statistical population, which is every ride taken at Boston all year round. To prep our dataset for analysis, we did the three-step listed here. First, we combined the ride dataset with the weather dataset using a VLOOKUP function in Excel. Secondly, we extracted a sample from the combined dataset using Python. As the original dataset was too big for our computers to process. Third, we converted the variable timestamp from an approach time to an Eastern time format using formula in Excel. This way, our audiences can better understand the variable.
Stepping into our analysis, we wanted to do exploratory research, and our goals were to develop an understanding of how our data is distributed, and we used histograms for that. Next, we wanted to identify if any of our variables had a relationship with pricing, and we used box plots to do that. Next, we used scatter plots to identify if our weather variables showed any trends in regards to pricing. First, we went into our data distribution, and we first looked at platform used. As you can see by the histogram, Uber actually came up a bit more in our data than Lyft did, so it was a more commonly used application. Next, we looked at the type of service used, and as you can see, it's actually pretty equally distributed. We account this to when we extracted our sample, that all categorical variables were actually attempted to be equally shown to maintain data integrity, and we actually did notice that for all our other categorical variables. Next, we wanted to look at the times Ubers and Lyfts were called on rainy days as compared to days with no rain. We hypothesized that days with rain would actually have more calls, but what we found is that it was actually equally distributed with a slight edge to days with no rain. Next, we looked at platform used and the type of service used. In platform used, you'll notice that the relation to price was actually pretty even for both Uber and Lyft. This made sense as they're competitors and they would have to remain parallel in pricing in order to remain competitive. What we did notice in types of service used was that based on the level of service, there was actually a difference in pricing. The luxury services like Uber Black and Lux actually had higher price ranges when compared to Shared and Uber Pool, which are the lower levels of both Lyft and Uber. So we concluded that the type of service used actually does affect the pricing of the Uber or Lyft ride. Next, we looked at the relationships between our variables in regards to price. First, we looked at location, both destination and source of trip. What you'll notice is that the price is actually pretty equally ranged regardless of location, but what we did notice was that when destinations, Boston University, Financial District, and Fenway had higher ends in terms of their interquartile ranges when regarding to price. As sources, Boston University and Financial District had the same instance. Now, this made us think that there was some type of a relationship between location and price, but nothing conclusive. Finally, we want to see if we could identify any trends in our weather variables. The four variables were temperature, rain, wind, and humidity. First, we looked at temperature, and we didn't notice any particular trend, but we did notice that lower temperatures tended to lower the prices of Ubers and Lyfts. Next, we looked at rain, and we didn't notice any noticeable trend, and it seemed that at all rain levels that were recorded, it seemed that Uber prices ranged between $0 and $70 at all levels. Finally, we looked at humidity and wind, and with humidity, we actually did notice a trend in that the less humid it was, the less the price of the Uber or Lyft was. We found this interesting as this data was taken in November and December in Boston, where humidity isn't really a factor that's very noticed in our weather. Next, with wind, we, similarly to rain, noticed that there was no particular trend, as at all wind levels, there seemed to be a wide range of prices.
Next, we are going to discuss the visualizations and analyses that we conducted within Tableau. When creating visualizations on Tableau, we had three goals in mind. The first of which was to leverage Tableau's ability to create geographical or map-based visualizations. Because our dataset included destination and source locations as variables, we knew that creating maps would be a great way to visualize other variables in a geographical context. Next, we wanted to define the relationship between different independent variables to confirm or deny pre-existing suspicions about Uber and Lyft rides. Specifically, the relationship between ride type and price, which we discussed a bit earlier. Our third goal was to compare more than two variables at the same time and leverage Tableau's unique ability to cut bar graphs by a third variable. This next slide is an example of one of the map-based visualizations that we created. Each location is a certain shade of blue depending on the average price of Lyfts and Ubers either taken from a certain location or towards a certain location. As you can see here, locations that are further away from downtown, like Boston University and Fenway, have higher average prices. That being said, later in our presentation, we'll discuss how the source and destination locations do not have a terribly strong relationship with the price of rides. The next visualizations included here are very similar to the ones listed prior. However, these instead have varying shades of blue depending on the average distance, either taken from or taken towards a certain location. Similarly to before, locations further outside of the city have higher average distances traveled either from or towards them. Next, we have bar graphs presented that are meant to display the cab or ride type's impact on the price. Each bar represents a location, and each segment of each bar represents the amount of cab types taken either from or towards each location. The purpose of this visualization was to determine whether certain cab types were popular in certain locations. However, as you can see from the relatively equal sizes of the segments, the results are fairly inconclusive. Next, we are going to discuss the regression analyses that we ran in Python.
Analysis and regression. So the statistical tests we consider were multiple regression and ANOVA. We chose multiple linear regression because it does a better job of measuring how a combination of X variables collectively affect a target value. Multiple linear regression model coding. We converted all our categorical variables to dummy variables. Our trained model was set to 70% and our test model was set to 30%. We used the sklearn package to run the regression model in Python. Regression model test and tweaking. We throw out date and time of day because we deem those variables unimportant. After our first two iterations of the regression test, we removed source, destination, and pressure because it improved our R-square value. Surge multiplier and Uber vehicle type played the largest role in price increase. Surge multiplier had a coefficient of 20.05, black SUV had a regression coefficient of 17.34, and luxury black vehicle had a coefficient of 7.21. Rain had the greatest inverse relationship with the price and had a regression coefficient of negative 2.52. Our R-square value was 0.4686. Multiple linear regression conclusions. Surge multiplier had the largest regression coefficient of about 20.05, which exhibits how demand has the largest effect on price. When demand increases, so does price. The type of vehicle one selects plays the second greatest role in price increase, with larger and more luxurious vehicles yielding higher fares. Rain had the greatest inverse relationship. When it rains, people stay indoors more, which decreases demand, ultimately decreasing price. Days of the week and other non-rain related factors all had small coefficients, meaning they had a minuscule paltry effect on price.
Here's our business question recap, and I will walk you guys through our finding. Firstly, we found that Uber does have more demand, although Lyft usually pays its driver higher. We also found out that Lyft has a stricter car requirement in comparison to Uber. Moreover, Sunday has the strongest relationship with price. Next, the amount of rain did not significantly affect the amount of rides. This may be due to the fact that more people are staying inside during rainy days. Moreover, neighborhoods further from downtown are more likely to have expensive rides, although such relationship between location and price isn't as significant. Last but not least, the search multiplier variable has the strongest relationship with price, but an ideal situation for Uber or Lyft driver also depends on the type of service and the distance of each ride.
Finally, looking at our interpretations, if you are an Uber driver in Boston, in order to make the most money, you should make sure you choose the right platform as they have different median prices. Try to drive on Sundays, avoid driving in the rain, make sure you're doing business in surge multiplied hours, attempt to have a vehicle that fits the higher service levels offered, and accept rides that have long distances. This combination would help ensure you get high prices for your services.